For part C, we've now got capital S of x, which is f of x times g of x, and we want to find the derivative of that. So mostly what they want you to do here, what they want to see is that you just really know the product rule. So the derivative of s prime, should be f times g prime plus g times f prime. Everybody agree that's the product rule?
Yep.
Yep. So for evaluating this at 4, so s prime of 4 should be f of 4, which would be 4 sine of root, whatever that is, that's 48 plus 5, 53, times g prime of 4, and g prime of 4 is 1, plus g of 4, which is 5, times f prime of 4, and f prime of 4, we'll be able to use our calculator to evaluate. Everybody good with that so far?
Yep.
Yep.
All right, so I'm gonna pull up the graphing calculator. I thought I was going to. Maybe I'm going to. Slowly reopening. It just crashed on me as I tried to share it. All right. So first off, what do we have? We had 4 sine root 53. And then we need to add to that, it was 5 times f prime of 4. So 5, and we can just put in here 5 times the derivative with respect to x. Oh, that's not what I meant to do. The derivative with respect to x of our function f of x, which was x sine of root 3x squared plus 5. And that's at x equals 4, right?
Yeah.
So hopefully you got 25.455. Is that what you guys got?
Yeah.
Perfect. Anybody have issues with that?
So for the problem before this,
Huh?
we had to actually solve for f prime and then use what we solved for f prime and plugged 2 into that.
No, I mean, you can use the calculator for that too. I had forgotten whether or not it was a calculator or a non-calculator problem. I went back and checked, and it was a calculator problem. So we could have just, we didn't actually need to find the derivative. We could have just used the calculator to evaluate f prime of 2 for us.
Okay, thank you.
Yep. All right, and then for part D, at 6, well, this is just a quotient rule. So it should be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. And we're going to evaluate each of those things at 6. So that should be g of 6 is 2. So that should be 2 f prime of 6 minus g prime of 6 is -3. So that'll be a plus 3 times f of 6 all over g of 6 squared, and g of 6 is 2, so 2 squared. Everybody good with that?
Yep.
And what'd you guys get for that? I'm not going to go back to the calculator and plug it all in, but what'd you guys get?
Like the final number?
Yeah.
-6.755.
How many of you agree with that? Does that sound good to other people?
That looks good.
Yeah, I mean, is that what you guys got? Did you guys all get negative 6.755?
Uh-huh.
All right. And then I'm going to trust that that's the right answer. Any issues or questions with that? It's actually not that difficult of a problem, right, overall, as long as you got a calculator to evaluate them all.
Yeah.
All right, let's look at one more, and then we'll let you go for the weekend. So I'm going to give you guys about 10 minutes or so to work on this one. And then from there, we will talk about it and then get out of here.
Is
Sound
this
good?
a calculator?
This one is a non-count. Oh, no, this is a calculator. Yeah, sorry, this is a calculator one.
Okay.
Yeah. Shouldn't really matter though. Part A is the only part you might have a little help with the calculator, just for the arithmetic. All right, take a couple minutes. So first off, for part A, we want to approximate f prime of 5.5 using the data in the table. So we can use any piece of this that we want to that surrounds 5.5, but what can we not use? We certainly cannot use any point that's at 6 or above 6, right? Because that's where our function changes, and at 6 we don't have a value here. So we could use the interval from 5 to 5.5. That would work, right? Alternatively, what other intervals could we potentially use?
Two and three. Wait.
Yeah, I mean, we could use 5 to 5.5. We could use 4.5 to 5.5, or we could use 4 to 5.5. But we can't use anything that includes a value at 6. So we couldn't use we couldn't even use the point 6.3 because that point's not actually defined. It just looks like we're approaching the point of 3 there. So what I would have done probably is use the 5 to 5.5. So I would have done 3.244 minus 3.455 all over 5.5 minus 5. And what does that come out to be? Is that the interval that you guys used or no?
Yeah, I used that.
Okay, so what did you guys get for that?
Negative 0.422.
Sounds good. Now in the AP test, there's not just always one correct answer, so that would have worked out. Like I said, if you'd used 4.5 to 5.5 or 4 to 5.5, those would have both been good as well. But not so good for us at the value of 6. Okay. Anybody have any issues with part A? All right. So for part B, we want to know if there's a value for x between 0 and 6, so that the limit as h approaches 0 of f of x plus h minus f of x over h equals 0. So what is the limit as h approaches 0 of f of x plus h minus f of x all over h?
The derivative of f of x.
That's just f prime of x. So we want to know, does f prime of x ever equal 0 on the interval between 0 and 6? And what should the answer to that be?
Yes.
It should be yes, and it should occur at x equals 4. because there's a horizontal tangent line there, right? Everybody good with that?
Yes.
All right, cool. So now if we're looking down here at part C, we got 3 different pieces to part C. The first part, this is a derivative at what value? This looks just like our difference quotient, right? Except that we've replaced the x's with what?
6s.
And there we go, replace them with 6's, right? And so this means the derivative of f at 6 on the, it's got a plus sign on it, right? On the, or from the right hand side, not on the right side, but from the right. So could I find the derivative of our function at 6 coming from the right hand side? What does it look like it is? It's a linear piece, it says, right? It's linear. And so what is that slope? What is the derivative of that?
One.
Not 1. That slope is
Negative 1/2.
negative 1/2. Yeah, good. And then what about this one? This one, kind of running out of space here. This one is f prime of 6 from the left, because it's got the minus sign there. So can I take the derivative coming from the left at 6, where there's an open space there? Can a derivative exist at a point that doesn't exist?
No.
No, right? There are 4 reasons why a derivative might not exist. F prime does not exist if we have a corner, if we have a cusp, if we have a vertical tangent line, or if we have a discontinuity there. And there's no point there, so we can't have a derivative there. So we'll say f prime of 6 from the left does not exist. And
Mr.
there,
Bassler?
Yeah.
But aren't we approaching from the left? So like we're getting like super close to it, but not getting to it? Or is it just, it's a derivative now, forget about the limit? part
well,
of it?
no, it's not that we're forgetting about the limit. It's that the derivative can't exist at a point where that piece of the function is not defined. So as we come from the left-hand side, 6 is not defined. And so therefore we can't have a derivative at that point. As we come from the right, 6 is defined on a continuous portion of it. And so we can have a derivative from the right, but we can't have it from the left because of the open hole there. And it's not because of the limit. We can still evaluate the limit as x approaches 6 from the left of f of x, but that's not the same as the derivative from the left. The derivative still has to have a defined point right there to have a tangent line there, to have a tangent line that has a slope there. Does that make sense?
Yeah.
Okay. And so if the derivative from the right is -1/2 and the derivative from the left doesn't exist, what do you think the two-sided limit here as h approaches 0 of 6 is? What's f prime of 6? Shouldn't exist, right? Because once again, we have a discontinuity there. It's not matching up on both sides. Good or no?
Yep.
All right, any questions on that?